After a journey across millions of kilometres, a machine touched down on a world far from Earth. Its mission was ambitious: to search for traces of life long vanished, but perhaps still written in stone. This is not the plot of a science fiction film, but one of the most daring scientific adventures of our time. The machine in question is the Perseverance rover, and its stage is the red deserts of Mars. What it seeks are not aliens as we imagine them in movies, but the fossilised remains of ancient microbes. If such evidence is found, it would prove that life is not unique to Earth, that the universe may be teeming with possibilities. In early 2021, Perseverance landed successfully in Jezero Crater. By the summer of that year, it was finally ready to attempt its main task: to drill into Martian rock and collect core samples that could one day return to Earth. These samples might answer one of humanity's oldest questions: are we alone? But the path to discovery is never simple. As we'll see, Perseverance's first steps into this uncharted terrain were filled with challenges, unexpected setbacks, and ultimately a triumph that brought us closer to uncovering Mars's hidden story. So let's retrace the months from June to September 2021, when Perseverance first reached out with its robotic arm and tried to capture the history of another world. Perseverance's journey began with its landing in February 2021. The mission marked a new phase in Mars exploration. Unlike its predecessors, which searched mainly for signs of habitability conditions that might have allowed life, Perseverance was built to seek direct evidence of life itself. The landing itself had been a stunning success using the daring sky crane maneuver, but after touching down, Perseverance didn't immediately begin drilling. Instead, it spent several months near its landing site testing equipment, calibrating instruments, and working with another remarkable machine, the small Ingenuity helicopter. Ingenuity demonstrated that powered flight was possible on another planet, something that had never been attempted before. Perseverance served as its communications relay and watched its flights with steady patience. Only after this initial phase of setup and support did Perseverance begin its real mission. By June, it was time to move away from its landing site and begin the long-awaited search for Martian samples. Let's pause for a moment and consider why Jezero Crater was chosen for this mission. Millions of years ago, a massive object slammed into Mars, leaving behind a crater 40 kilometers wide and several hundred meters deep. Over time, this depression filled with water, forming a vast lake. Rivers carved valleys into the surrounding terrain and deposited rich sediments into the crater, creating massive deltas. For scientists, this combination of ancient water and deposited silt makes Jezero a prime candidate for preserving signs of life. On Earth, river deltas are teeming with life and are excellent at burying and preserving organic material in sediments. If Mars followed similar rules, any microorganisms that lived in Jezero's waters might have been trapped and fossilised in the rocks below. Of course, the Mars of today is dry, barren and cold. Any signs of life would be microscopic fossils hidden deep in the rock layers. That is why Perseverance carries advanced tools to cut through the Martian surface and collect samples sealed in tubes, samples that might one day tell us if Jezero truly hosted life. So Jezero Crater is more than just a landing site. It is a window into Mars's watery past and perhaps its biological past as well. To achieve its mission, Perseverance is equipped with a powerful set of tools. Mounted on a 2-metre robotic arm is a drill capable of two main tasks: grinding away the outer surface of rocks to expose their inner layers and coring cylindrical samples about the size of a stick of chalk. These samples are placed into airtight tubes, carefully sealed to prevent contamination. Perseverance carries just over 30 of these tubes, meaning every choice must be deliberate. Each tube is a potential treasure chest, holding secrets from billions of years ago. To decide where to drill, Perseverance uses advanced instruments: Sherlock, an ultraviolet spectrometer, can detect organic molecules, while PIXL, an X-ray fluorescence spectrometer, maps the chemical composition of rocks in exquisite detail. Together, they help scientists choose the most promising targets. Tempting as it might be to take samples immediately at the landing site, Perseverance needed to be strategic. Not all rocks are equal in their scientific value. The best candidates are those that can reveal either signs of ancient life or critical details about the age and history of Jezero Crater. So, the rover prepared to leave its landing zone, named Octavia E. Butler Landing, and set out toward a region called the Cratered Floor Fractured Rough. It was here that Perseverance would make its first real attempt to drill. The distance to Cratered Floor Fractured Rough was little more than a kilometre, yet it took Perseverance nearly 2 months to get there. Why so long? The Martian surface is littered with hazards, sharp rocks, uneven terrain, and soft sand that can trap even the most capable rover. Spirit 1 of Perseverance's predecessors met its end when it became stuck in a sand dune. To avoid such a fate, Perseverance had to move cautiously, selecting its route carefully. But Perseverance also had an advantage. Its autonav system, a kind of artificial intelligence, allowed it to map its surroundings and chart its own course, even while moving. This made it far more autonomous than earlier rovers, which had to wait for instructions from Earth, a process slowed by the 20-minute signal delay. Thanks to autonav, Perseverance could travel 6 times faster than Curiosity, though faster is relative. Its top speed is just 0.12 kilometers per hour, slower than most of us walk. Imagine taking 2 months to cover the distance from your home to the local grocery store that is the patience of interplanetary science. Still, progress was steady. By July 20th, Perseverance had arrived at the Cratered Floor Fractured Rough, ready to attempt its first drill tests. The first test came with a rock scientist nicknamed Guillaume. Perseverance used its abrading drill to scrape away the surface. This was a success, revealing the inner layers and allowing scientists to study grain size and mineral composition. Encouraged, they selected a more ambitious target. On August 6th, Perseverance drilled into a rock named Rubion. Over 90 engineers and scientists gathered online in the middle of the night, eager to witness the rover's first attempt to collect a core sample. At 2 a.m. Pacific time, Perseverance's drill bit into the Martian surface, coring down to 7 centimeters. Initial images showed the hole, and everything appeared to be going perfectly. The rover carefully transferred the core into a sample tube, sealed it, and placed it into its storage system. Scientists celebrated what seemed to be a flawless operation, but then more data arrived. The tube was empty. Confusion spread. Had Perseverance dropped the sample? Had the process failed? The rover's cameras had not captured every detail, so the answer wasn't immediately clear. But soon, weight sensors confirmed the truth. No rock had been collected. The cause was not Perseverance, but Rubion itself. The rock had crumbled into powder during drilling, disintegrating before it could be collected. Despite extensive testing on Earth with dozens of rock types, this scenario had never occurred. On Mars, however, the unexpected had happened. For the team, it was a bittersweet outcome. Perseverance had functioned perfectly, but the first attempt at a core sample had vanished into dust. Questions arose: would other rocks behave the same way? Was Mars itself too fragile to yield samples? The mission faced uncertainty, but NASA was determined to try again. Not far from the failed site, Perseverance's cameras spotted a group of rocks that looked far sturdier. Jutting from the ground, they resisted erosion in a way the flat paving stones had not. Scientists nicknamed them Citadel, from the French word for castle, hoping these rocks would prove more resilient. Perseverance approached the site and prepared for a second attempt. On September 1st, the team once again gathered anxiously. This time, the process was deliberately cautious. Every step was checked, double-checked, and confirmed. The drill penetrated the rock and extracted a 6-centimeter core. Before sealing it, Perseverance paused. In a move that almost seemed like wry reassurance, it lifted the sample to its camera and took a picture. The image showed exactly what everyone on Earth needed to see: a solid core of Martian rock. This time, success was undeniable. The core was transferred into a sealed tube and stored safely. Scientists named the sample non-denier. To reinforce the triumph, Perseverance collected a second core that same day, ensuring redundancy. The relief among the team was immense. After months of preparation and a frustrating failure, they finally had in their possession the first samples of Martian rock that could one day return to Earth. Each tube now represented a tangible step toward answering the question of life beyond Earth. The success at Citadel marked only the beginning. The cores collected in September 2021 may not themselves contain evidence of life, but they demonstrated that Perseverance could fulfill its mission. Over the months and years to come, more tubes would be filled, each one a time capsule of Mars's ancient history. We have not proven that life ever existed on Mars. Not yet. But with every sealed tube, we move closer to finding out. And isn't that the essence of exploration, to take one careful step after another, even when the outcome is uncertain? Someday, perhaps in the next decade, these samples will arrive on Earth, where entire laboratories can probe their secrets. Until then, Perseverance continues its slow, steady work under the cold skies of Mars. As long as energy flows through its batteries and empty tubes remain, the rover will keep searching. And we, watching from millions of kilometers away, continue to wonder, are we truly alone in the universe, or is Mars waiting to whisper a different story?